Good day everyone. This morning we will have to discuss about trigonometric functions and right angle. For our objectives, we have to evaluate the 6 trigonometric functions, define and evaluate the right angle. So we have here our trigonometric functions, namely the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent function. Cosecant is the inverse of sine, the secant is the inverse of cosine, and cotangent is the inverse of tangent. And class, take note, the shortcut for sine we have SIN, and the colored portion of our trigonometric function, as you can see on our PowerPoint, is the shortcut of our sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. So we have here the acronym SOHCAHTOA. So did you hear this acronym, class? So we will have to know what is the meaning of SOHCAHTOA. So if this is our right triangle, class, then this is our angle theta, which is our reference in order to find where is our adjacent side, our opposite side, and our hypotenuse. So let's learn what do you mean when you say the acronym SOHCAHTOA. So let's start with the we have sine is equal to opposite over hypotenuse. So if this is our reference angle, or this is our angle theta, so we have here opposite leg over hypotenuse, therefore opposite over hypotenuse. And then we have next the ka, which stands for cosine is equal to adjacent leg over hypotenuse. So let's show if where is our adjacent leg over hypotenuse. So adjacent over hypotenuse. And we have for our TOA, which stands for tangent is equal to opposite leg over adjacent leg. So we have opposite leg over adjacent leg. How about for next, as I mentioned a while ago, sine, the cosine, and the tangent, we have also the inverse of our function, which is the cosecant, the sine, and the cotangent. So, therefore, we have the acronym of SOHCAHTOA, which the inverse of SOHCAHTOA, which is the SOHCAHTOA. So, what does SOHCAHTOA means? So, we have cosecant is equal to hypotenuse over opposite leg. So, therefore, this is our angle theta. We have hypotenuse over opposite leg. And we have the SHA, which stands for secant is equal to hypotenuse over adjacent leg. So let's show on our triangle, we have hypotenuse over adjacent leg. And then we have for our cow, which stands for cotangent is equal to adjacent leg over opposite leg. Therefore, we have adjacent leg over opposite leg. So let's try this one. We will have to find the 6 trigonometric function of an angle A. So if this is our angle A, class, so here is our angle A. And then we have for our measurement, we have, so before we proceed, class, let's identify first what is our opposite leg, our hypotenuse, and our adjacent leg. So if this is our angle A, so if the side, so this is our opposite leg. So if at the front of your angle, so this will be your opposite leg. Take note, class, if at the front of your angle, so this will be your opposite leg. And beside your angle, this is your adjacent leg, and the longer leg, that slant, this is your hypotenuse. So therefore, the value of our opposite leg is equal to 8.2, and the value of our adjacent leg is equal to 23.1, and the value of our hypotenuse is equal to 24.5. So we already classify our given. So let's find the sixth trigonometric function. So let's start with sine. So we all know that sine, the value of our sine is, our formula is opposite over hypotenuse. So what is our opposite leg? We have 8.2, and for our hypotenuse is 24.5. So therefore, the value of sine A is equal to 8.2 over 24.5. And then next, we have our cosine A. So we all know that cosine A stands for adjacent over hypotenuse. So based on our triangle given above, so we have our adjacent is 23.1 and our hypotenuse is 24.5. So therefore, the value of cosine A is equal to 23.1 over 24.5. Next, we have for our tangent. So tangent A, our formula for tangent is equal to opposite over adjacent. So therefore, our opposite is 8.2 and our adjacent is 23.1. Therefore, the value of tangent A is equal to 8.2 over 23.1. So again, how can we find this one? So take note of our acronym, which is SOHCAHTOA. So next, we will have to find the inverse function of our SOHCAHTOA, which is the SOHCAHTOA. Let's start with cosecant A. So for cosecant A, our formula is hypotenuse over opposite leg. So therefore, we have hypotenuse is 24.5 and for our opposite leg, which is 8.2. Therefore, the value of cosecant A is equal to 24.5 over 8.2. So as you observe, plus, as I mentioned a while ago, sine and cosecant. So cosecant is the inverse of sine. So therefore, whatever value you get on the sine function, so you will have only to get the inverse of our function. So in your based on your sine A, 8.2 is on our numerator. For our cosecant A, the 8.2 or our opposite leg must be on your denominator on cosecant A. And then the 24.5 here on our sine is on our denominator. So for our cosecant A, it is on our numerator. So same with our cosine, the inverse of cosine a while ago, as I discussed, is the secant, while for tangent and also with the cotangent. So let's find the value of our secant A. So for our secant A, we all know inverse of our cosine A. So therefore, our formula is hypotenuse over adjacent leg. Therefore, we have our value is 24.5 over 23.1. So therefore, we have here inverse. So take note. Just get the inverse of our cosine A. So for our tangent A, for our cotangent A, we have inverse of tangent. So our formula therefore is so for our formula here, so just get the correction only, class. So therefore our formula for cotangent A is adjacent leg over opposite leg. So adjacent leg over adjacent leg. So just correct the class, our formula. So therefore, for our adjacent leg is equal to 23.1, and for our opposite leg, which is 8.2, or simply get the inverse or reciprocal of our tangent. So therefore, we have 23.1 over 8.2. So we already have our sixth trigonometric function. Take note, class, again, sine is inverse of cosecant. I mean, cosecant is the inverse of sine. So therefore, whatever value you obtain on the sine, the cosine, and the tangent, so you will only have to inverse in order to get the value of our cosecant, the secant, and the cotangent function. So let's have this one. For each of the following diagrams, select the correct trigonometric ratio to solve for the numerals. So for number one, we have, which is our first triangle, class, here it is. So we will have to classify or determine what trigonometric ratio we will have to use. So in order to find for the appropriate trigonometric ratio, so we will have to first to identify what is our given in order to determine what will be the trigonometric ratio we will have to use. So if this is our angle, class, this is our angle theta. So, at the front of our angle, this is our opposite side. Therefore, the value of our opposite side is x. And this is our hypotenuse, which is the 15 centimeters. So, therefore, the given value is opposite and hypotenuse. So, therefore, what trigonometric ratio we will have to use if the given is opposite and hypotenuse? So, again, you will have to go back on the acronym of SOHCAHTOA, so we will have to use the sine function. So we will have sine is equal to opposite over hypotenuse. So therefore, our opposite side is x. And our hypotenuse is 15 centimeters. Therefore, our sine theta is equal to x over 15 centimeter, or x over 15. So, and as I mentioned a while ago, sine is inverse of our cosecant. So therefore, the value of our cosecant theta is equal to, just get the inverse of our x over 15, which is 15 over x. So let's have the number 2 example. So for number 2, let's determine first our given in order to determine what trigonometric ratio we will have to use. So if this is our angle theta, so at the front of your angle theta is 10 inches. So therefore, this is our opposite leg or opposite side. And the x is our hypotenuse. So therefore, we have opposite and hypotenuse. So what trigonometric ratio we will have to use? So we will have to use the sine function. So why is it sine? Because our given is opposite and hypotenuse. So from our acronym SO. So we have opposite over hypotenuse. So what is the value of our opposite? We have 10, and the value of our hypotenuse is x. So therefore, the value of our sine theta is equal to 10 over x. And the value of our cosecant theta, inverse of our sine, which is x over 10. Okay, take note, class. Sine, just get only the inverse in order to get for our cosecant. So let's have another example. So for our given number 3, so determine our given. So if this is our angle theta, at the front of our angle theta is 30 meters. So therefore, this is our opposite side. And beside is x. So therefore, this is our adjacent side. So we'll have, if the given is opposite and adjacent, the trigonometric ratio we will have to use is the tangent function. So therefore we have tangent theta, opposite is 30 and adjacent is x. So therefore the value of our tangent theta is equal to 30 over x. And for the inverse of our tangent is the cotangent, which is just get only the inverse of our tangent function, which is the adjacent over opposite. So therefore adjacent is x and our opposite is 30. Therefore the value of cotangent theta is equal to x over 30. So next example. So let's identify our given. So we have here, beside this is our angle theta. So beside of our angle theta is 25 centimeter. Therefore, this is our adjacent leg. And this is our hypotenuse, which is x. So our given is adjacent and hypotenuse. Therefore, if we will have to recall the SOHCAHTOA, the trigonometric ratio we will have to use is the cosine function. So we have cosine function. Our formula is adjacent over hypotenuse. So the value of our adjacent here is 25. So therefore 25 and the value of our hypotenuse is x. So therefore the value of cosine theta is equal to 25 over x. And get the inverse in order to get for our second theta. So for our second theta, we have hypotenuse over adjacent. So our hypotenuse is x and our adjacent is 25. So therefore, we have second theta is equal to x over 25. For number 5 example, we have, if this is our angle theta, so at the front of your angle theta is y. So this is our opposite side. And we have our longer leg, which is our hypotenuse. So therefore 20 is our hypotenuse. So our given is opposite and hypotenuse. So again, recall the SOHCAHTOA. So therefore we'll have to apply the sine function. So sine function class, opposite over hypotenuse. So therefore, opposite is y and our hypotenuse is 20. Therefore, the value of our sine theta is equal to y over 20. And for our cosecant theta, we have hypotenuse over opposite. So therefore, opposite 20 and we have opposite is y, or simply we have get the inverse of y over 20, which is 20 over y. Okay, good. So we will have to proceed. We have right triangle trigonometry. So if this is our right angle class, this is our angle theta. This is our right angle, so which is measures 90 degree. So let's identify where is our opposite, our adjacent, and our hypotenuse. So if this is our angle theta class, we have, this is our longer leg, which is our hypotenuse, and we have at the front of your angle theta, as I mentioned a while ago, this will be our opposite side. And beside of your angle theta, this is your adjacent side. So let's have an example, or what does it mean to solve a right angle? So in solving a right angle, you will have to find the unknown parts. You are usually given one side of a right triangle and 1 of an acute angle, and asked to find of the other sides. You are also given 2 sides and asked to find 1 of the acute angle. So to understand more, let's have an example. So we will have to find the value of a and the 6 trigonometric function. So we will have to find the missing side of our right triangle. So if this is our right triangle, class, this is our angle theta. So here are our sides. So we will have to first determine our given. So if this is our angle theta, our opposite side is A, which is missing. So we will have to find the measure of our opposite side. And then beside of our angle theta is 5. Therefore, this is our adjacent. So the measure of our adjacent side is 5. And we have here for our hypotenuse is equal to 13. Okay, so class, if you still remember the Pythagorean theorem. So what does the Pythagorean state? So our Pythagorean theorem states that the square of our hypotenuse is equal to the sum of the square of our 2 legs. It means, class, if you will have to square our hypotenuse, it is equivalent to the sum if you will have to square the opposite side and the adjacent side. Opposite side you will have to square, and adjacent side you will have to square. You will have to add this one, and the result will be your hypotenuse, and you will have to square. Or again, Pythagorean theorem state that the square of our hypotenuse is equal to the sum of the square of our 2 legs. So our 2 legs are A and B, and for our hypotenuse is C. So therefore, we have for our opposite side, which is A, which is missing, and for B, which is our adjacent side, which is 5, and then we have our C is 13. So we will have to square this one. Therefore, 5 plus, we will have to square this. So just simply square the 5 here. Or we will have to get 5 here. So just square the 5 here. So we will have to have the square of 5. So you will have to square the 5 here. In order we will not confuse. Okay, so let's continue. So we have A, which is our missing, plus you will have to square the 5, which is the square of 5, which is 25, and the square of 13 is 169. And then we have, so our goal, class, is we will have to get the value of A. So therefore, we will have to transpose the 25. So if we will have to transpose the 25 to the right side, so since we already transpose, class, we will have changed the sign of our 25. Inverse of positive 25 is negative 25. So therefore, this will be the reason why we have minus 25 here. So we have our result, A squared is equal to 169 minus 25, and 169 minus 25 is 144. A squared is equal to 144. So our goal, class, is we will have to get the value of A. So our next goal here, we'll have to find strategy, or we'll have to think how can we cancel the squared. So as you all remember, recall your algebra class, in order to get the square here, so you will have to get the square root of our a squared. So if we will have to get the square root of our a squared, so since we already get the square root of a squared, so we will have to get also the square root of 144. Why is it, class? So whatever you do on your left side, you will have to do also on our right side. So that will be our rule. So we have the square root of a squared is equal to, we have get the square root of a squared and get the square root of 144. The square root of a squared is equal to a, and the square root of 144 is equal to 12. So this is the value of our opposite side, which is 12. So therefore, this is the value of our a, or this is the value of our opposite side. So we can determine which will be our sixth trigonometric function, or what will be our sixth trigonometric function. So let's have first the sine function. So we have SOHCAHTOA. So SOHCAHTOA sine is equal to opposite of over hypotenuse. So therefore opposite is 12 and our hypotenuse is 13. So therefore we have sine theta is equal to 12 over 13. And next, for our cosecant theta, get the inverse of our sine function, which is 13 over 12. Next, for our cosine theta, we have cosine theta is adjacent over hypotenuse. Therefore, we have adjacent is 5 and our hypotenuse is 13. Therefore, cosine theta is equal to 5 over 13. And then, to get for our secant theta, we have get the inverse of our cosine theta. We have 13 over 5. For our cotangent, for our tangent and cotangent, we all know we have tangent function is equal to opposite over adjacent. So therefore we have opposite is 12 and our adjacent is 5. Therefore the value of our tangent theta is equal to 12 over 5. And next, we have for our cotangent, get the inverse of our tangent, which is 5 over 12. Okay, next, how about if we have here an angle 27 degree. So here is our so class, on our last example, we have only the angle theta. But here in our example, we have 27 degree is the value of our angle. So we will have to figure out which ratio to use. Find the missing letter, round to the nearest tens. So we have, let's determine first our given. So 200, this will be our adjacent side. And we have, this is our B is our hypotenuse. So our given is adjacent and hypotenuse. So therefore, we will have to use the cosine function. So for cosine function, we will have our formula is SOHCAHTOA. So we have adjacent over hypotenuse. Therefore, the value of cosine 27 degree is equal to 200 over B. Take note, class, there is a given value of our angle which is 27 degree. So, this is cosine 27 degree na siya. Is equal to 200 adjacent over hypotenuse, 200 over B. So our next goal here, we'll have to get the value of b. So in order to get the value of b, so we'll have here cross multiply our equation, which is b cosine 27 degree is equal to 200. So class, we will have to get the value of b. In order to get the value of b, we will have to cancel the cosine 27 degree. So how can we cancel the cosine 27 degree? So divide your whole equation into cosine 27 degree. Divide here. b divided by cosine 27 degree. So we'll have to cancel the cosine 27. Therefore, we have b. So b is equal to 200 over cosine 27 degrees. So therefore, using your calculator, class, you will have to get the value of our b. So therefore, you will have to just simply pass the 200. So we have 200 divide cosine 27 and then close parentheses. So class, don't forget the parentheses. So there are times na if you will have no parentheses, so your answer will be the syntax error or math error. So here it is. So we have here 200 divided by your cosine 27. So therefore, we'll have to so we have here for our answer is and then equals. So therefore, our answer is 224.4652475. But according on our problem, so round to the nearest tens. So therefore, our answer is b is equal to 224.5. Okay, another example. Figure out which ratio to use. Find the x, round off to the nearest tens. So this is our angle, 55-degree angle. So let's identify our given. So at the front of your 55 degree is x. So therefore, our opposite side is x. And this is our adjacent, which is have a value of 20 meters. So therefore, we have opposite and adjacent. So what trigonometric ratio we will have to use? We have the tangent function. Therefore, we have tangent function. So SOHCAHTOA, we have opposite over adjacent. Therefore, we have the value of tangent 55 is opposite, which is x over 20. So therefore, cross multiply, we have 20 tangent 55 degree. So is equal to your x. So again, using your calculator, class, we have 20 multiply by your tangent 55. Then close parentheses, we have 28 point. This is 28.6. Here it is, class. We have here 28.6. 28.56. So therefore, we'll have to round off to the nearest tens based on our problem. So 28 point. So the tens here is 5, and at the right of 5 is x. So therefore, we'll have to round off. So therefore, we have 20. Our answer is 28.6 meter. So don't forget the unit of measurement, which is meter. Okay, next. What if we'll have to find the value of our angle? So on our last example, we have already the value of our angle. So what if the missing is our angle? So let's have an example. We have find the value of our angle, theta, round off to the nearest tens. So if this is our angle, so first we will have to determine our given in order to find what trigonometric ratio we will have to apply. So we have here, this is our angle theta. At the front of our angle theta is our opposite side. Therefore, we have the value of our opposite side is 17.2. And beside of our angle theta, which is our adjacent side, therefore, the value of our adjacent side is 9. So we have opposite and adjacent. So what trigonometric ratio we will have to use? We have the tangent function. So for your tangent function, we have SOHCAHTOA, opposite over adjacent. So we have for our opposite is 17.2 and our adjacent is 9. So therefore, we have tangent theta is equal to 17.2 over 9. So in your calculator class, in order to get the value of our angle, so in your calculator, search for shift or second function. So in your calculator, press shift or second function. And then we have the tangent function. And then next, you will have to press 17.2 and then divide 9 and then close parentheses and then equals. So we have the value of our angle is 62.3789 degree. So again, class, our goal is we have to get the value of our tangent theta. So based on our problem, we have round off to the nearest tens. So therefore, we'll have to round off this one. We have the value of our tens place is 3. So at the right of 3 is 7. So therefore, our answer is 62.4 degrees. So don't forget the degree symbol here. In order to classify, this is our angle. So therefore, the value of our angle theta is 62.4 degrees. So let's have another example to understand more. So we'll have to find the value of our angle round to the nearest tens. So this is our angle theta. So what will be our given? So beside of our angle theta is 7. So therefore, this is our adjacent side. And we have here our longer leg, or this is our hypotenuse. Our given is adjacent and hypotenuse. So what trigonometric ratio we will have to use? Again, SOHCAHTOA. So therefore, we'll have to apply the ka, which is cosine is equal to adjacent over hypotenuse. So adjacent is 7 and our hypotenuse is 23. So therefore, we have cosine theta is equal to 7 over 23. And then again, in your scientific calculator, just press shift or second function. Shift or second function. And then we have the cosine function. And then next, 7 divide 23, and then close parenthesis, next equals. So in your calculator, it displays the value of our angle is 72.281 degree. And we will have to round off to the nearest 10. So since 2 at the right of 2 is 8, therefore our answer is 72.3 degrees. So again, we have the value of our theta. Angle theta is 72.3 degrees. Okay, and for more clarifications and in order to you will not confuse class, when we are trying to find the side of our triangle, we will have to use the sine function, the cosine function, and the tangent function depending on the given. So you will have to recall, you will have to apply the sine function if the given is opposite and the hypotenuse, SOHCAHTOA. And if the given is adjacent and hypotenuse, we will have to apply the cosine function. And if the given is opposite and adjacent, you will have to apply the tangent function. When we are trying to find an angle, we use the shift tan or the angle function. We have the shift tan, the shift cosine, and the shift sine in your calculator. So take note class, you will only have to use the shift or the second function if you will have to find the angle. So let's have the application of our right triangle. First, we have the angle of elevation. So the angle of elevation, the angle measured from the horizontal to the top of the object in question. So the angle of elevation to the top of a fir tree is shown in the diagram. So when we say angle of elevation, you will have to find from the top of a horizontal top. So if you will have here, we have here a diagram. So if this is our angle, or here you stands in this angle, you will have to look at the top of the tree, or you can have a look at the top of the building, or any kind of object that have an height. So for this is your line of sight, and this is if this is you stands. The distance between you and at the bottom or at the base of our tree, this is your horizontal. So let's have an example. So for our problem, a surveyor is standing 115 feet from the base of the Washington Monument. The surveyor measures the angle of elevation to the top of the monument as 78.3 degrees. How tall is the Washington Monument? So let's understand our given. So to make it easy, we'll have to draw a diagram. So this is the Washington Monument. And then this is you standing at the base of our monument. So here is the surveyor standing on the monument, and the line of sight or the angle of elevation of the surveyor to the top of the monument is 78.3 degrees. So this is the angle of elevation of the surveyor to the top of the Washington Monument, which is 78.3 degrees. And from the surveyor, the place of surveyor to the base of the monument the distance is 115 feet. And the question is, how tall is the monument, or what is the height of the Washington Monument? So let's have this one sketch which assigned a variable y. So this is our angle, and this is our measurement. So let's identify our opposite, our adjacent, or our hypotenuse. So if this is our angle here, so at the front of your angle is your opposite. So our opposite side is y, and beside of our angle is our adjacent side. Therefore, the value of our adjacent side, which is variable x, we have 115 feet. 115 feet, therefore we have opposite and adjacent. We call the SOHCAHTOA. If the given is opposite and adjacent, we will have to use the so for our solution, our opposite is 115 feet. For our adjacent is y, which is the height of your monument, and our angle is 78.3 degrees. So therefore, we will have to apply the tangent function. So for tangent function, opposite, which is y, and adjacent is 115 feet. Therefore, we have cross multiply, we have 115 tangent 78.3 is equal to y. So using your calculator class, you will have to pass 115, and then tangent 78.3 degrees, close parenthesis. Therefore, we have our answer is 555.3139. Or we have our answer is y is equal to 555.31 feet. Therefore, the height of the Washington Monument is 555.31. Okay, so let's have the application of angle of depression. So, what do you mean when you say angle of depression? So, angle of depression, the angle measured from the horizontal down to the object in question. So, when we say angle of depression, you are at the top, and you will have to look at on the bottom. So, for angle of elevation, you are from for angle of elevation a while ago, you are below, and then you will have to look at the top of a building or any kind of higher object. In angle of depression, you are at the top, and then you will have to look down on an object. So for example, so from the top of a lookout tower, the angle of depression is of a small fire is 77 degrees and 20 minutes. If the height of the tower is 100 feet, how far from the base of the tower is the fire? So let's understand our problem. Okay, so this is our lookout tower, and the angle of depression is 7 degrees and 20 minutes. And we have here the fire, and the measure of the height of the tower is 100 feet. And then from the fire, we have our angle of depression is 7 degrees and 20 minutes. So our question is, from the fire to the base of our lookout tower, what will be the measure of this one? So if this is our angle of depression, 7 degrees and 20 minutes. So therefore, we have, if this is our angle, we have for your angle, at the front of your angle is x. So therefore, this is your opposite side, and this side of your angle is 100 feet, which is the height of the lookout tower. So therefore, we have, this is our adjacent side, opposite and adjacent, therefore SOHCAHTOA. So therefore, we will have to apply the tangent function. So we have here, opposite is the base of a tower or fire, adjacent is 100 feet, and our angle is 7 degrees and 20 minutes. So tangent 7 degrees and 20 minutes is equal to x, which is our adjacent leg, and then we have here for our opposite is x, and for our adjacent is 100 feet. So therefore, cross multiply, we have 100 tangent 7 degrees and 20 minutes is equal to the distance between the fire and the base of the tower. So therefore, what will be the distance? X is equal to, just plus 100 tangent 7 degrees and 20 minutes, which is 12.86 feet. Therefore, from the fire to the lookout tower, the distance is 12.86 feet. Okay, so for more clarification, feel free to message me on my Facebook account or Messenger on our GC, or you can have comment on the video. Thank you everyone, and have a good day.